Let's talk about motion of a charged particle in a uniform magnetic field. As you can see, because of magnetic fields, the charge is making circular motion. So can I say F net equal ma because of centripetal force? Can I write this one using mv square over r? Yes. This one equal magnetic force. I mean magnetic force equal centripetal force mv square. Even we can open the magnetic force q v b. Why I wrote this one? Because just we'll talk about the magnitude of force. What's the angle between V and B? Please look at here. V is going this side and the magnetic field is inside of the page. Can I show like this? The angle is between magnetic field and force is 90. So I can say this is 1. If we cancel some of quantity like this, for example, R will be mvqb. This is our radius. We can ask some question about the radius of circular path. Also, can I write angular speed of particle? Yes, you can use it. For example, I know the angular speed equal velocity over r. Instead of r, I can write this one. V mv qb. I can cancel v. Now our angular velocity will be qb m. There is another formula, which is the period of motion. We call as a t. How can we calculate it? Actually, it is quite easy. X equal vt. I know x equal vt for the constant speed. I can use this one. For circular motion, what's the x? I start from here to same position. What is my distance? Of course, it is circumference. Is it right? Instead of x, I can write 2pr vt. T is now period. T equal 2pr over v. Even you can write r using that formula. Now your t will be 2pmqb. You can see all formula with the clear version on here. Okay, let's solve a question using that formula. Proton moving this a proton is moving in a circular orbit of radius r is 14 centimeter. Be careful, you have to convert to meter. In a uniform magnetic field, just I will write the B, perpendicular to velocity of proton. Find the linear speed of proton. What's just I will show here again. You have like this. Maybe you can't see. It's not visible. It's the charge starts from here. It turn around like this. Say this is r. And the magnetic field is perpendicular to velocity. Say this is your velocity. The magnetic field, for example, is inside of the page. You can see. Say this is velocity. Magnetic field be inside of the page like this. What's find the linear speed of proton? How can we find it? It is quite easy. If you remember the formula, you can just find the velocity. Which one should I use? What's your idea? Maybe we can come back here. If they give mass and charge, and also magnetic field, I already know R, I can find the velocity, is right? Just I will take that formula. If you take that formula, velocity equal R QB over M. They have to give R and they have to give Q and M. They didn't give here. I will take some copy from my slides. Give me a second. I already know Q, but I have to take mass information. Now, for Q, for Q, 1.6, 10 to minus 19, and for R, this one, B is 0.35, and we have to give a proton mass, which is very small number. So your velocity will be meter over second. 4.7 multiplied 10 to 6 power meter over second. You can see, if you know the formula, you can calculate the result. Look at that question. In experiment designed to measure the magnitude of uniform magnetic field, electrons are accelerated from rest through a potential difference of 350 volts. The electrons travel along a curved path because of the magnetic force exerted on them. And radius of path is measured to be 7.5 centimeter. What is the magnitude of fields? We have to find B. I know delta V. We know the delta V. They say the electrons are accelerated from rest. When you see electrons start from rest, please try to remember energy conservation. We generally use that one. If I say total energy is conserved, I have to write this one. At first part, it start from rest, mean the velocity is 0. I mean the kinetic energy is 0 as well. Okay, nice. For Kf, can I write minus potential energy difference like this? Can I write this one? I know this one is potential energy difference. And also I can write this one Q delta V. Did you remember this one? I think from chapter 25. We already know this one. Just we have to put that information, and we need to open the velocity part. Minus Q multiply delta V. I have to find velocity firstly. I will come here. If I write everything here, the velocity will be, I have to forget the minus, otherwise I will explain when I show the formula. 2Q delta V over mass. If I take minus, the root square, the inside of root square will be minus. It is not acceptable. Just we are trying to find the magnitude. Okay, let's continue. And when we put everything inside, the result will be that one. Okay, now we find the velocity. What was asking? What is the magnitude of field? How can we find? I know velocity. I know radius. Is there any other information? No. Can I use? I know velocity. I know radius. They have to give charge and mass. Can I take B from there? Yes, you can find it from that formula. And magnetic field will be mass over R, Q, R. Just I have to put everything inside. When I put everything inside, the result will be Tesla. Okay, look at B. What is the angular speed of electrons? Angular speed, velocity over R. We already know the velocity. We already calculated. Over the radius is 7.5 multiplied 10 to minus, because I have to convert centimeter to meter. And then the result will be 1.5 multiplied 10 to 8 radius over second. It's okay. Do you have? I hope you don't have any problem. But also in the answer part, they wanted me to convert radius to revolution. Do you know, one revolution, for one revolution, we have to finish 2 pi parts. I mean, one revolution is 2 pi radian. So how can I convert W? You can write like this. Radius over seconds. I want to cancel radius parts. So you can write 1 revolution over 2 pi radian. So the result will be, I am sorry, I don't have enough space. That's one revolution second.